All right, what up, dudes? Okay, so it looks to me like chapter two is due this week when I'm looking at this. And I've already spent three lectures on chapter two. And then it looks to me like, or not chapter two, but Algebra 1 Review Part 2. And then this is Algebra 1 Review Part 3. And it looks like this guy is coming up in the next, well, obviously I haven't assigned it yet. It's assigned for next week. So I've got some breathing room, so here's what I'm going to do today. I got some of you calling me and freaking out and saying, Mr. Dalday, I need to drop your class. Your class is just so hard, it makes my face melt off, and I'm just like dying here. And, all right, fine. That's an over dramatization. But I do have students who are wanting to drop my course, especially if they're in both my algebra and my chemistry course. And I feel like this year I'm doing a lot of accommodations. Um, I do have due dates, and those are important to follow. But I do close the quizzes well after the due dates. So technically, even though I say that I don't accept late homework, you guys can turn it in as long as it's before the close date. Some of you have even asked me to open up the quizzes again so you can have, another try because the quiz closed already. And I don't think in every single instance that we've had, I've never said no. I've always opened it up to you folks. So there's that right there. The other thing is, if you used up all of your attempts, people have asked me, hey, can you give me, more attempts? And I've never not given you the attempts that I've always given you the attempts every time you've asked. Let's see. Are you talking about this video right here, Sophia or Lucas? Oh yeah. That one's just worth 2 points. Watch it. You don't need to do it like right now. I mean, you should watch it now. You should watch all of these videos. I think these videos were from last year, and then these videos were from this year, but this is all the same curriculum, so maybe I explained it differently last year than I did this year. All right. We can watch it for reference order. Yeah, exactly. It is kind of an assignment. You do get 2 points for watching it. Just click true on both of them and you get the 2 points for free. All right. So here's what. So that's that. And here's another thing, is some of you have pointed out that, oh, hey, Mr. Dalday makes a lot of mistakes. And while I do make a lot of mistakes, I don't make as many as you think that I do. Another thing is, I don't know if you've noticed this. Actually, I can't do this right now. I shouldn't go back. Because I don't want to show you everyone's grades. That wouldn't be cool. But I don't know if you've noticed this, but when you check your grade book, I've hidden inside of your assignments, there's this thing called teacher's comp. I don't know if you noticed it. All right, here's what it is. All right, it's my I keep tally of all the mistakes that I made, and then what I do is I give you points, or I keep track of all the mistakes I made, and then I made up this assignment called Teacher's Comp, and it's just my way of compensating for the mistakes that I made. And so this is like a 30-point assignment, and I gave everyone 30 points. So it's like you took a quiz that was worth 30 points, and you aced it. That's the equivalence of it. And when I add in those kind of adjustments, that I think well makes up for any mistakes that I made. So that's what I did. So I did two things to kind of say, look, I'm sorry for making mistakes. I gave you guys 30 points out of 30 points. Also, whenever I do make a mistake, I correct them. Also, I give you guys as much time as you need. So here's what I'm going to do in addition to all of this stuff is I'm going to reluctantly cancel what I was going to talk about today and fix any mistakes that I have in any of my things. in any of my courses. So, or not in any of my courses, but in this course specifically. So today's class will end at 12:45, or will end at what time? 2:10, and it's going to be open to tutoring. Do you need help? Which problems would you like help on? Why don't we take, and you know what, I'll even take a look at what homework is coming up and show you folks what the ideas for those would be. Chem will be on at 2:15, and it's going to be kind of the same thing, but I do have some things I need to lecture on. Got it? Can we practice graphing quadratic functions? Absolutely. I love quadratic functions. All right. Some of you have had trouble with the graphing calculator that I provided, and I told you I would take a look into that. I still haven't done that. It should work, but if it doesn't work, here's what I would recommend doing. Go to Desmos. This app is actually an app that I pushed to all of your or to your Chromebooks already. So it might even be a little symbol on the bottom. I forgot what that symbol looks like, but it might be a little icon on the bottom or somewhere in your apps button. And you go to Desmos and you can graph these quadratic equations like y equals 3x squared minus 4x plus 2. Something like that. I'm not on a Chromebook. I'm actually on my Windows machine because I like using the pen feature. So today's class is for anyone who needs tutoring, because I got plenty people signing up for like tutoring on tomorrow, and they want tutoring like, oh, Mr. Dolde, can I get some tutoring one-on-one? And I'm like, yeah, that's fine. But I'll tell you what, why don't we just open up the class today, and I will not do my lecture that I had planned today, and I will give it to you guys as a free class for open tutoring. Ask me questions. I'm waiting patiently. I'm not angry. All right, so what's going on? Okay, Madison, you need to tell me more than 10. And Bradley, I'm assuming by what you say by today's homework, you're talking about the one right here. Is this it? Right here? Altitude 2.3? Okay, all right. Let's take a look at it. How does the graph... Oh, okay, wait. This is more of an essay question. You guys should answer. You guys should just type that in. Huh. Oh, okay. This is, even though you can't type in question 2, I asked that over here. This is 2 part A. All right. Let's do question 10. What is the range of this function? Oh, okay. Awesome. I love doing these ones. Check this out. Is this a happy face parabola or a sad face parabola? This is happy. How can you tell it's happy? Actually, you know what? I'll tell you what. I don't want to solve your homework problem directly for you. I'm just going to solve a problem like it. How's that? I'm going to make up one off the top of my head. Okay. All right. Is this a happy or sad face parabola? This is a sad face parabola. Absolutely. And you can tell because of the negative. Yes, because of the negative right here. Is this parabola on the slim fast plan or the Whopper plan? Is this a fat parabola or a skinny parabola? Okay, it's a sad parabola and it's skinny. I like to think of it as vertically stretched gummy bear, which is also the version of skinny. Exactly. And then this parabola, is it moved? Do I push this parabola up or down? Down. By how much? by 4. No. 2, exactly. I move it down by 2. This moves it up and down. This number right here does not push the parabola physically up and down. This number vertically stretches it by a factor of 4. So if I were to make a very ugly back of my notebook, or like back of a piece of napkin graph, it would look something like this. 1, 2, an extra skinny parabola going down like that. Something like that. Does that make sense? All right, awesome. So the range of this is y is less than or equal to -2, because it's saying the y values can be everything below -2 and down. What y values are allowed? Everything below -2. Does that make sense? So I think that when I ask you a question, you can't type in y is less than -2, less than or equal to -2. So what I do is I ask you this in 2 parts, and I say, all right, is your answer going to be a greater than or equal to, or a less than or equal to? And for this particular problem, you would just say, you would check that one. And then the next part is, I think I ask you, okay, what's the number? And you would put in -2. So in giving your answer for this part, I actually ask it as 2 different questions, and I ask it as, is it greater than or equal to, or less than or equal to? And you just check this box, and then you do the -2. And Sophia, actually, you're right. You're right in talking about if a parabola, if the a value over here is a positive number, then you're probably going to be dealing with a greater than or equal to version, because you're talking about a parabola that goes up like this, even if you had to pull it down, because you're talking about the y values can be all the values above this number right here. All right, Bradley wants to talk about problems 1 through 8. Let's talk about that. See, a lot of people said, whoa, that's way easier than I thought. Yeah, it kind of is. All right. It looks like 1 through 8 is all referring to this problem right here. Identify ax squared plus c for the various values of a and c. Okay, if a is 2 and c is 3, then the vertex is located at what point? Okay, so ax squared plus c, if a is 2 and c is -3, did they say -3 or +3? I don't remember. A is 3, c is 3, so it's 2x squared plus 3. Okay, all right. Happy face parabola or sad face parabola? Happy face, awesome. What does the 2 do? Tell me about that. It makes it thinner. Okay, it vertically stretches the parabola, making it skinnier. What does the 3 do? And no, Carmen, it's not the y-intercept. What does the 3 do, though? Three moves it up. It pushes the whole dang thing up 3, exactly. So your parabola would look right here. What is the x and y coordinates of the vertex? 0, 3. So I think that what I do is I ask you this in 2 parts, and I say, well, what is the x coordinate? And you would put in 0. And then I ask you, what is the y coordinate? And you would put in 3. Bada bing, bada boom. That's it. Hey. That's what I'm talking about. Can I put that in the graphing calculator? Of course I can. I can put it in the graphing calculator. I'll tell you what, I'm going to use Desmos since I just told you about this new Desmos thing. Let's put in 2 x squared plus 3. Okay, there we go. 2x squared plus 3. That vertex is located at 0, 3. Any questions, comments, concerns, vomits, etc.? See, you guys realize Mr. Dallday's class isn't as bad as he makes it out to be. I have a vomit on 2. Okay, well, what's your vomit? How do you find the vertex of ax squared plus bx plus c? Sophia, let me answer that question after. Do I ask you anything about that? I have no idea why I say questions, comments, vomits, etc. I think my 9th grade English teacher used to say that. He said questions, comments, vomits, etc. And I thought it was funny, and so I say it now. All right. Okay, let's see. Question 11, please. All right, Madison, why don't we cover question 11, and then what I'll do is I'll move on to the next part. All right, let's see. Oh, this one right here? Yeah, -2. That's it. Because this question 10 and 11 were tied together. Does that make sense? Question 10 and 11 were tied together. Question 10, the answer to question 10 is that y is less than or equal to -2. And so what I do is I don't know how to have you folks, everyone, type in the same answer as y is less than or equal to -2. If you folks were writing that up, but you turn that in and I'd be happy. But in this way, I ask the computer to tell it to me, ask it to you twice, and I just say, here's the less than sign, and then I want the number. So this is question 10 right here, and this is question 11. Oh, wait. I don't know if the answer is -2 because I used, I made up a problem, whereas this is a different problem. But what I'm saying is it would just be a number. Here's my question to you. Bummer. Audio check. Audio. Hello. All right, cool. Sorry, no, the network just failed all of a sudden. I reconnected it. I should be good. All right. Here's my question to you. See this 4 right here? No. Darn. Now the other computer blanked out. What happened? Sophia's big blue button kicking you out because it kicked me out a couple times. Okay, all right, ready? I'm sorry. All right, so, why does a computer add 0.000 to every answer? It's just I don't know. That's kind of their thing. I don't know why it does that. All right. All right. Here's my question. Do you see this 4 right here? Does everyone see that? All right. My question is, you know this answer right here? This one right here? Would that number, does the 4 affect that answer? Like, for example, -3x squared minus 2. Or Yeah, sure. Let's make it negative 3x squared. Oh, why is your... Okay, there we go. What is the range for this equation? Okay. What I mean is, no, I'm not talking about the positive or negative sign. I'm talking about the actual number. You see, I apologize if the audio keeps cutting out. But yeah, exactly, Bianca. It would be the same exact answer. The only difference is with this one, you would have a little bit fatter parabola. But the range would be the exact same. I just want you to notice this. Notice these things. Look at how these numbers change. Okay. Now, I want to take a look at question or homework 2.9, which is also, it's not due now, but it would be good for us to take a look at. And then I was thinking about answering Sophia's question. So size doesn't matter, but the sign does. Yeah, I guess that's one way you could say it. And I could make a joke there, and I decided not to because I'm better than that. All right, let's take a look at this real quick. 2.9. Is this the one you were talking about, Sophia? All right. 2.9. Let's take a look. Oh, okay. So this one's pretty straightforward. Yes, Lucas, what's up? Okay, all right. All right, so check this out. Let's find an interesting problem. All right, I'm just going to make up another problem. These are actually kind of fun. All right. So check this out. You ready? Y equals, I don't know, x plus 4 times x minus 3. Okay, there we go. Got it? And we'll slap on a negative out in front of over there. Sound good to you? All right. So this right here is in called factored form. Write this down. Everyone take out pencil paper. Write this information down. This is good stuff. This is called factored form. Why? Why is that? Well, because the equation's factored for you. I want to put it in this thing called standard form, which is not really especially helpful to us at all, but I'll show you kind of what to do. You simply FOIL it, and that's pretty quick and easy to do. That would be x squared minus 3x plus 4x minus 12, and I have to slap on a negative out in front still. Because all I did was I FOILed this part, and then I still have that negative to deal with. So I'm looking at x squared, or negative x squared, minus x plus 12. All right, I did a couple of steps there. Make sure, as you write it down, you folks are like, oh, I get it. That's pretty easy. Yeah. All right, got it. So, from this, oh, wait. How does the negative 12 become the positive 12? Well, because I applied the negative to everything. So this becomes, maybe I'll do the middle step right here. This becomes x squared plus x minus 12. And then I need to distribute this negative into everything. So this is negative x squared, negative x, positive 12. I just happen to do this middle part in my head. Yeah, no worries. All right, cool. So this is in standard form. These are equal to each other. They just look differently. Their clothes are different, but they're the same person. They're the same parabola. They're just wearing different clothes. They look a little bit different. Got it? So from this form right here, you can tell me a little bit about the parabola. Let's kind of talk about what this parabola does. Is it a happy parabola or a sad parabola? All right, frowny face. Good. What is the y-intercept? 12. Awesome. Technically, you would want to put 0, 12, because if I'm asking you for a point on the graph, you need to give me two numbers. But if it's always the y-intercept, it always starts with a 0, of course, so maybe that's why you didn't include it. But yes, technically, you would want 0, 12. All right. All right, so that's really all the information we can get from this equation right here. Is it a happy one? Is it a sad one? Is it scrunched up, or is it, flattened out? That kind of stuff. All right. The information that we can get here is really nice. We can figure out what the x-intercepts are very easily. And I'll tell you what they are. That it's either x is equal to negative 4 or x is equal to positive 3. Any questions about that? How did I get the negative 4? Okay, well, simply this. I took the factored form, and I said, well, if I'm finding the x-intercept, I always set y equal to 0. So I have 0 is equal to negative x, that's a horrible x, negative x plus 4 times x minus 3. Are we coolios with that? And then I multiply both sides by negative. That becomes negative 0, and it makes it a positive. Negative 0 is still 0, so then that, that doesn't matter over there. Then I can say, if this times this is equal to 0, then either x plus 4 equals 0, or x minus 3 equals 0, and then I solve for x, and I get x equals negative 4, which is right here, and I've got x equals positive 3. So are we cool with what I have here so far? Okay, cool. Now, what I can do is I can say, if I were to plot this on a graph, I can say, it looks like the leftmost x-intercept is negative 4, so 1, 2, 3, 4, right here. And the rightmost intercept is positive 3. So I've got two intercepts, and there's right here. Got it? I know the y-intercept is 12, all the way up here at 12, way up there. My question is, what does this graph, what is the vertex of this graph? That's a little bit trickier to figure out. And actually, it's not that bad. I'll show you. It's actually pretty cool. You ready? The vertex will occur halfway, exactly halfway, in between the two x-intercepts. Because parabolas are symmetric. So in order to figure out where is exactly halfway on between two numbers, I average them. How do you average two numbers? Well, you add them both up together. So it's negative 4 plus 3 and divided by 2. That would be 1/2, or negative 1/2. Sorry about that. Negative 0.5. Exactly. So when I asked you, what is the x-coordinate of the vertex, you should put in negative 0.5. Or negative 0.5. I think both of them. This is the x-coordinate of vertex. Does that make sense to you? It's the average of the two x-intercepts, not x-coordinates. The two x-intercepts. Okay. What is the y value of said vertex? All you have to do to find the y value of the intercepts is check this out. This y is the same thing as f of x, right? This is saying I have some kind of equation that has an input and an output. For any x you give me, I'll tell you what the y value is. I'll tell you what comes out. And if your interested point, if the point that you're interested is x equals negative 0.5, then all you do is you find, well, what is f of negative 0.5? Which means you rewrite this equation up here, or this equation, it doesn't matter, they're both the same. And instead of wherever you see an x, you put 0.5 or negative 0.5. And I'm betting that your y value is going to be a positive number. In fact, I'm just thinking about it off the top of my head. I'm betting that it's going to be a number that is bigger than 12. Well, exactly, Sophia. I think it's going to be a positive number because we're looking at a parabola that's a frowny face parabola. And if we have these 2 points, it would have to be something like this. My other conclusion, and I'm just telling you folks the way I'm going about this in terms of doing this in my head, is the vertex is going to be some number bigger than 12 because it's this point right here. And this point right here is already at 12, so I think that it's going to come up higher than that and then come back down. Not that much higher. I would say maybe 12 and a half or something like that. That's my guess. Let's graph this thing and go to Desmos and then figure this out. Let's see. Good old Desmos. I think what I was graphing is negative x plus 4, x minus 3. Oh, there we go. Okay. So the vertex is at negative 0.5. I don't know if you can see that right there. Negative 0.5 and at 12.25. So it's a little bit bigger than 12. It's a positive value and it's at negative 0.5. The x-intercepts are at 3, 0, and negative 4, 0. So boom, from this equation right here, I can pretty much tell you everything about my graph. Everything that I would like to know about how my graph looks. Do you guys understand the procedure? Does it make sense to you? Or, I mean, like this stuff is like, oh yeah, I can see how I can do that. Yeah, okay. All right. For once. Yeah, finally it makes sense, Mr. Dollar, because everything you explain is always so confusing. All right, Ethan, shoot your question. Go for it. Today is your day, open day for tutoring. No question is a dumb question. No question is ever a dumb question, but, I mean, especially today. How's that? I just want to see who exactly is here. All right, let's see. All right, Ethan. So the line meets at 3, but is written in the form negative 3. What is the color of my underwear? To be honest with you, is gray. It's gray. Okay, and then also, Ethan, to answer your question, I'm just that good. Yeah. Anyway, are you talking about this -3 right here, Ethan? Okay. What we did was we ended up, I asked you to solve a bunch of these, and I did this inside of the class before. X minus 5, x plus 6, or something like equals 0. And then we said, okay, we have two things multiplying by each other and totaling to 0, or equaling to 0. I shouldn't say total because that makes you think add. So we have two things multiplying each other whose product is 0. So the one conclusion, or the three conclusions that I could draw, is either the first is 0, the second is 0, or both of them is 0. Right? And so I say either x minus 5 equals 0 or x plus 6 equals 0. Then what I do is I solve for x. In this case, x equals -6 and x equals +5. Just take the 6 over to the other side and the 5 over to that side. Yeah, you always do it that way. But actually, I take that back. Maybe we always do it this way, but then after a while we got so good at this stuff that we were like, we went straight from here that we were just like, oh, I can just pretty much say that x equals 5 and x equals -6. We kind of discovered that it's kind of the opposite of whatever the sign is over here. Does that make sense? So maybe I did it really quick, and maybe it seemed like magic to you. But that's kind of why I did it. All right. You have to be careful, because I didn't give you a problem like this, or at least I don't think I did. But what happens if we had something like this? 2x minus 4 times -x plus 2 equals 0. Or let's make it a 3. All right. That immediate guess that I would say is, I would say, okay, either x is equal to +4 or x is equal to -3, right? This is just looking at this, and I say, oh, hey, this number is -4, so I'm guessing +4. This number is +3, so I'm guessing -3. All right. Yeah, exactly, Sophia. So if I were to be more careful, I would say, no. Let's try this. 2x minus 4 equals 0, or -x plus 3 equals 0. And I solve for x to get it all by itself. This would be -x equals -3, so x is equal to +3. Excuse me, I'm sorry. Let me take this real quick. Hello? Can I call you back? Who's calling? Okay, what's the number I can call you? 432-5100, and who do I ask for? Okay, thank you. Bye-bye. Sorry, my, oh, yeah. No, well, you can call that number if you want. That's the number to Kaiser. You guys remember I talked about how my wife is sick, and so I just want to make sure she's all right. Okay. So over here I get x is equal to +3. And then over here I get that 2x is equal to 4, so x is equal to 2. So in this case, both of my guesses were wrong, and these are the actual answers. So all I'm saying, Ethan, is that the official way of doing it is this way. This is the safe way. This is the way that will get you the right answer. The problem is it might be the long way. And there's no problem with doing things the long way, because if we took the shortcut for this problem right here, we'd get it wrong. Whereas we did it the long way, we were careful enough to go through it systematically, and we got the answer correctly. So really, when you see the pattern, use the trick. But if you, if you say, that doesn't look exactly the way I like doing things, and yes, I actually like Safeway. I get my cheese from there. It's called Mazither cheese, and sometimes they have things that I need that isn't at Foodland. But technically, I like using Foodland better. But what I'm saying is, this is the right way to do things right here. So I'll let you figure out which one is which, and then just try a bunch of them and see if your answers are correct. We cool? I felt like today was a good tutoring session. Do you mind if on chat? So tomorrow, I'm actually going to open up a class at 8:30, and it's just open tutoring for a student, but everyone's invited. I'm just going to open up the class and tutor until I can catch this person up. Acacia, you're invited too, because I think you emailed me about it too. On Wednesday, I want to hit chapter 3 stuff, if that's all right with you. Actually, you know what? Since today I opened it up to everything, that better be all right with you. That's what I'm going to say about that. All right, I got to go so I can get chemistry class started. So anyone's got any last minute questions? Good. You know what you should do is some people email the counselor and say, Mr. Daldy doesn't explain things or whatever. If I do a good job at explaining, go email the counselor and say, Mr. Daldy did a great job explaining. That'd be good. I think I'm going to start my tutoring session at 8:30. 8:30. Yeah, you should say stuff like, oh yeah, he's the best teacher I ever had. No, you know what? I'm not going to, because I'm recording this, so they could be like, oh, we're getting all these emails. Let's go take a look at his class. And then they'd be like, oh, wait, Mr. Daldy told everyone to say that. So, you guys get to do what you guys want. I'm not going to sway you either way. All right. Okay, bye.